Yes, Abdur Rahman, tell me.
No, sir.
Why? Adriel, what about you? Did you do this? Yes, Adriel. I'm not asking that. It was for today. Okay. You have the lectures with you. You can ask for notes from me. You can ask the notes from me. There is, I mean, I don't know why you're giving this reason of old notebook. Right. Yes. What about Mithun, by the way? Mithun, did you try to do this?
Sir, actually, I joined your classes a bit late, so I just completed the nomenclature. So
Only the nomenclature. No, nomenclature was only one lecture.
No, basically, I just completed everything in that and just started the preparation of Haloalkane. So by tomorrow,
nomenclature was only one lecture. So that means you completed one lecture or two lecture, let us say, if you include the classification.
Yeah, and also the previous class I just revised, so I couldn't get time to watch it.
What about Kinza? You were present in the last lecture, Kinza?
No, sir.
Did you watch the lecture then?
Sir, I didn't get the lectures. I searched it on YouTube, but I didn't get it.
You searched on the YouTube. What did you search?
I searched from the playlist you have sent, but I didn't get it.
No, see, playlist may. You search in the playlist, that means you just scroll the playlist.
No, I have seen every lecture, but
Like,
I didn't get the same lecture which you have got.
So the last lecture that has been uploaded here is, it would be what, 1st of August, right? Kinza, do you have my phone number?
Yes, sir.
Okay. So if you don't get something, then you will message me. Okay.
Okay, sir.
Well, MEE. It's true that I also can't see that. So math is chemical properties of. Oh, this is 21, but. It's not there. Okay. So Adil, can you please turn the mic on? Yes.
Yes,
Adil.
sir. Hello.
So that question was about chlorobenzene undergoing hydrolysis. Okay.
Yes, sir.
So hydrolysis means you will add water here. Okay, you will add water here. Now adding water, it means that you're adding H plus and OH negative ions. Now instead of water, you can use aqueous KOH and aqueous NaOH also. It means the same thing. Whenever you have this word hydrolysis, you may treat it with what? Aqueous KOH or aqueous NaOH also. Because for this chlorobenzene, we have our OH negative, which is my crucial ion. And this OH negative can also be, we can also get OH negative from KOH and NaOH also. So in last lecture, we saw that, no? If we have just the chlorobenzene, we need to use a drastic condition, right? Did you write the notes, Adriel? आप तो notes शायद नहीं लिख रहे हैं, right? Did you write the notes, Adriel?
Which lecture, sir?
Last
one?
lecture.
Yes, yes.
You have written. So see here. This one. We are using drastic condition, high temperature and high pressure, right? So what you can write when what happens on the hydrolysis of chlorobenzene, we will write 2 points. At room temperature, it does not show reaction, first of all. Okay, right? But this is very important at room temperature. At room temperature, no reaction. Okay, but on drastic conditions, it shows SN and forms phenol. Okay, and then you will show this reaction. Chlorobenzene. First we have NaOH, and we have here 623 Kelvin, 300 atm pressure. Second step, we add H plus in the presence of water to form OH, phenol. Got it?
Yes, sir. So for exam, suppose like they didn't mention the temperature and pressure, like.
So you write both the things. You will write this point also. At room temperature, there will be no reaction. Then you will write, but on drastic condition, it shows SN and forms phenol.
Okay.
Okay. At least for this, you have to remember the temperature. Or if you don't remember the temperature, then you will write here high temperature and high pressure. Okay. You will put in whatever information you have. If you don't remember this exact temperature and pressure. But I remember this. From the benzene ring structure only. So we have 6 carbon and there are 3 pi bonds. And the relation between 6 and 3 is that if 3 2s are 6. So I remember it like this. Okay, so you can have some mnemonics whenever the temperature and pressure are important. Okay. Assalamu alaikum, Fahad. How are you? Yes, hello, Fahad. Am I audible?
Yes, sir.
Okay. Did you do this homework?
No, sir.
Why?
I have to do.
You have to do?
Yeah.
No,
Sir,
I
actually,
asked.
I couldn't write in the last lecture. So I was not knowing what was the homework.
But you have the recordings, right? You have the recordings, na?
Yes.
Okay.
So also, can you send me
But till when we have to submit it?
No, you don't. You have to send it to me. और वो आज करना था आप लोगों को. Today was the day, and it was important today that you should submit it. Why? Because I told you guys, right? I will be doing conversions today. Do you remember all the reactions of haloalkane, haloarene, guys? All of you. I'm asking this to all of you now. Do you guys remember all of the reactions right now of haloalkane, haloarene? No, na. I think nobody remembers all the reactions as of now. Is there anyone who remembers all the reactions of haloalkane, haloarene, whatever we have done till now? Yeah. Is there anyone? No one is there, right? And all of the reaction that is present in your notebook, it is one reaction is in one page, the other reaction in the other page. What I needed was all of the reaction in a condensed form. So if I was talking about the preparation of haloalkane, then you will have one page in that you will have all the reactions. Now today I will be doing conversions, but it will be one more thing I told you guys is to do what? One more thing I told you guys is to watch the conversion lecture. Yes or no? I gave you a link to watch the lecture, right?
Sir, I made like the for exams when I was learning, I made this like short steps for the preparations. Can I send you that?
Send me that, whatever you have done. Guys, do you remember? I told you guys to watch a lecture on conversions.
Yes, sir.
Did you watch it? I gave all of you guys one link also now. Yeah, I gave the link in the previous class. And Kinza, I think you have, what is the playlist name? Can you tell me that I gave to you? What is the playlist name, Kinza?
Yes, sir. 1 minute.
Mm-hmm. Yeah, organic conversions, right? Yes, Abdul Rahman. Sahil, I will send it to you. Now, one thing I think you all should do something. Go to YouTube and write Learnivio. Class 12th also is there, I think, or just 12th. No, 12th. Go to YouTube, write Learnivio 12th conversions. Organic conversion.
Sir, I do have the video. Do I need to send the link in the chat to you? So that
No, you
can...
don't. No. I also have the link, but I'm sending. I'm telling this to all of the other students that they can get the lecture by themselves also.
Yeah.
There are 3 videos, right?
Yes, sir.
Okay. So yeah, you choose for what I would say. You choose the 12th MEB. There is one with 12th MEB. You can choose that. I think that is the latest one.
It's about 2 hours, that one.
Yeah. Less than 2 hours. Yeah. Fair. What can I say now? And how many of you have prepared for the test solutions? याद भी है कि नहीं याद है किसी को?
Yes, sir.
No, you will have the okay. You'll have the test after the class, okay? Half an hour. Okay, let us start. Organic conversions. Now, please remember, guys. First thing that you have to do is attend the live classes. Okay, you have to attend the live. Then if you don't do anything, at least revise this class. And don't revise just by reading. No, you don't have to read anything. ठीक है, novel नहीं है यहाँ पे chemistry. You have to practice things now, so you will write things. Now, it doesn't, I mean, no matter if it is organic chemistry, physical chemistry, or inorganic chemistry, you will write the reactions in organic chemistry, main concepts in organic chemistry. You will do the problems in physical chemistry, and you will write again the chemical reactions and important points in inorganic chemistry. And whenever I'm saying you have to revise, that means you have to write and you have to shorten the notes. Okay, you have to shorten the notes. Whenever I'm saying revise करने का मतलब ये नहीं कि novel की तरह पढ़ रहे हैं बैठ के, newspaper reading नहीं है ये. Okay, so whenever I say revise, and this is the least you can do. If you can't attend the live lecture, then what you have to do? Wait for the next day, and then when the lecture is getting uploaded in the YouTube, you watch the lecture. And then again, make notes and then revise. Make notes and then revise. Now you have a gap of 1 day in between your chemistry classes. So what you can do is always, if you ever miss the lecture, please watch that lecture before the next lecture. Okay, for example, Monday ka lecture miss hua, then on Tuesday you will get the lecture, then Wednesday you have a class. So you will watch on Tuesday or you will watch on the Wednesday morning, and then you will attend the class on Wednesday evening. Okay, then I gave you this one small homework of writing something from your notebook, and that also you are not doing. So you write whatever homework you have. Please keep a track of things. Otherwise, time will pass on and you will not gain anything. Now, Haloalkane, this is the last class, and you don't even have the reactions in one page. Now let us see how many organic conversions can you do now.
Sir, I sent
How will
it.
you refer? How will you refer back to that reactions? Muhammad Umar, did you get the link? Tell me.
Yes, sir.
Yes, so I mean, something like this only you have to do. Okay, something like this only you have to do. I can't see, by the way. Only Markovnikov's in preparation. SN is not there. Actually, SN is not there, hai? So some things are missing, but similar to this Adriel. Similar to this.
Okay, sir.
See, there are two things that you should have always before attempting even what I'm writing. Not in order to get an expertise or to get the expert level organic conversions. Even if you want to attempt the organic conversions, then you should have two things at least. You should know the IUPAC nomenclature in and out. You should know the IUPAC nomenclature in and out. Now, I'm not saying that you have to know the common names right now. I know there are many common names that you will not be acquainted with. So don't worry about the common names. You will get all of these common names by the end of the whole organic chemistry portion. Then you need the reaction maps. Initially, when you are attempting, you need the reaction maps. But in exam, what you will have, you will have some patterns in your head. Okay, there will be some patterns in your head, and there will be some points that I will be showing you guys that what are the patterns that are repeating, what are the important reactions for conversion. Okay, there are some reactions that are specifically important for conversions. Okay, so those reactions we will see, and there are also some sequence which are important. Okay, that means if this reaction is happening, then the next reaction will be this or this. Okay, so this type of sequence is there, that is again coming under the pattern. Now in your NCERT textbook haloalkane haloarene, there are 30 conversions, out of 30 there are 2 repeated. 2 questions are repeated. That makes 28 unique conversions. And I will be doing all of these 20 unique conversions in today's class. If I cannot do in today's class, then I will be doing in the next Monday class. Okay, if there is some reactions which are left over. Now, to start things off, please write this. Now, the first step will be always to draw the starting material, and target molecule. My starting material is chlorobutane. So the structure of chlorobutane will be, one chlorobutane specifically will be 1, 2, 3, 4 carbon atoms, and the fourth carbon atom is containing a chlorine group. And I have to convert this to N-octane. So there will be 8 carbon atoms. So 1, 2, 3, 4, 5, 6, 7, 8. Now, whenever you have, there are 4 carbons, and here we have 8 carbons. Now, what is the reaction in which there is a doubling of carbon atoms?
So with
Which
KC
reaction? With
KC.
doubling of the, यही तो है केसीन वाला रिएक्शन देखी, डबलिंग हम बोल रहे, डबलिंग डबल कहां से हो जाएगा केसीन? क्लोरीन है, if you add KCN here, I have 2 carbons. Now you will have 3 carbon atoms. That is it.
Sir, what's the reaction?
So
Woods reaction, correct. It will be Woods reaction. Doubling of carbon atoms. Woods reaction. What is the reagent for Woods reaction? Tell me. What is the reagent for Woods
Sodium and
reaction?
dry ether.
Dry ether.
So not dry ether. Please remember,
Sodium
dry
and
ether
dry
is
ether.
not. Sodium is the reagent. Only sodium is the reagent. Now we use dry ether as a solvent. Hai sodium is what? It is a metal. It will be solid. Okay? And we cannot put it in water. Why we can't put sodium in water? Tell me, guys. You know what happens, right? If we put sodium in water,
Highly reactive.
what happens?
Explodes.
It explodes, it catches fire, and etc. That is why dry ether. And again, what is dry ether? Dry ether is only ether without any moisture. Okay, so sodium in dry ether. All of you got this? Yes or no? Riz, are you getting these things?
Yes, sir.
Hana? Okay, fine. Just stop me if you don't get something here. Okay.
Sure, sir.
No. Right, the next one here. See, Acha, one more thing, you will see that the sequence of question that you are seeing in my slides, it is very different from what NCERT has put. So I have grouped all the conversions, like similar conversions in one section, and then I have grouped some other one, some other like this. So I have grouped the similar conversions. So you will see that, see, again, chloroethane. Ethane means how many carbons? 2 carbons. Butane means 4 carbons. Now we see that there are many questions in which what we are getting the Woods reaction type of thing, or there is a doubling of carbon atoms. So you will write a note and you will think of this as a mental framework that whenever doubling of carbon happens, think of whenever doubling of carbon happens, think of sodium in dry ether. So I can't write only Woods reaction because there is Woods reaction and Fittig reaction and Woods and Fittig reaction. All of these, they use the same thing, sodium in dry ether, and they also end up in the same thing. That means there is a doubling of carbon atoms. It is just the difference that we use haloalkane in one case, we use haloarene in the other case, and we use both of them in the other case, that is Woods Fittig reaction. So in chloroethane to butane, what we will have? This is 2 carbons, chlorine, and it will go to butane, 4 carbons, again in sodium and dry ether. Sodium in dry ether. Now they can ask you some question like this also. For example, if you have ethanol, OH, okay, then how will you convert it to butane? So again, you can see there are 2 carbons here. There are 4 carbons here, right? There are 4 carbons here. So whenever there is doubling of carbon happening, you will think of again what sodium in dry ether. And we know sodium in dry ether will react with what? It will react with RX, haloalkane or haloarene. And here you can see that first I can convert this to haloalkane. I will use SOCl2. I will get chloroethane, and then I will use sodium in dry ether. Okay. So this is how conversions get complicated after a while. Okay. So please write this one. Only write this one here. Achha, wait a second. Don't write. You don't have any doubt here, yes or no?
No.
Once you're done with the class, if you get this chloroethane to butane, then you can do it on your own, right? So what I will be doing here, I will be explaining you all of the conversions, but you will not note down anything particular. I will tell you when you have to note down something, if there is something important. Okay. So you write down this part here. Whenever doubling of carbon happens, think of sodium in dry ether. Think of sodium in dry ether. Whenever doubling of carbon happens, think of sodium in dry ether. Now, I can't even say that always use sodium in dry ether, but there is one case that you will always think of sodium in dry ether. And you will try this reaction. Okay, so organic chemistry is not like what we can say. It is not like physical chemistry where you have, let us see, for example, the concentration of solution you will get is that 2.1 moles per liter. There is no other answer for, I mean, other than 2.1. Here you can get some other answers also. Let us move on to the next. Write this: 2-chlorobutane to 3,4 dimethyl hexane. So 2-chlorobutane will be like this, and we have to convert this to, this is hexane, and we have 3. Here we have CS3, and here also we have CS3 in the 4th position. Now again, you can see we have 1, 2, 3, 4 carbon atoms, and here we have 1, 2, 3, 4, 5, 6, 7, and 8 carbon atoms. Right. So here we have 8 carbon, and there we have 4 carbons. Again, there is a doubling. So what we are going to try? We are going to try sodium in dry ether. Now, all of you must remember from our classes that we form the product something like this. I write the I write the haloalkane without the halogen 2 times, and then join the carbon which contained halogen atom. Now we will get this type of molecule. If I number it 1, 2, 3, 4, 5, and 6. So as you can see that there are 6 carbon atoms, and we have CS3 groups in the 3rd carbon and the 4th carbon. Very similar to this case: 1, 2, 3, 4, 5, 6. That means both of these molecules are same. We have just written it in different forms. If you remember, we have done this reaction in the class also. You will find this reaction in your notes also. Okay, so 2-chlorobutane to 3,4 dimethyl hexane. Now, one more thing that you will understand here is the importance of IUPAC nomenclature. If you don't know how to draw this 3,4 dimethyl hexane, then you will not be able to also get the reagent, that is sodium, in the presence of dry ether. Right, next one, benzene to, now see here, what do we have? Benzene to biphenyl. Benzene we have, and what we are converting it to? We are converting this to biphenyl. What is the reagent we will be using? Tell me, guys. What is the reagent we will be using here? What is the reagent? What is happening? What is biphenyl? Biphenyl is 2 benzene rings connected. What reagent will I be using here? What reagent?
Sodium in dry ether. Sodium.
See, sodium in dry ether. See, this is where you fall into the pitfall. एक ही चीज लग रहा था, सोडियम एंड ड्राई ईथर के लिए क्या चाहिए? हैलोअल्कीन चाहिए या हैलोअरीन चाहिए? Yes or no? We can't do reaction with benzene. Yes, है ना? We can't do reaction directly with benzene. We need a haloalkane first. Yes or no, guys? Correct?
Yes, sir.
Yes, है ना? I hope you recognized it now. So first of all, what we are going to do, we are going to convert this to haloarene. We'll convert this to haloarene. And what we are going to use? We can use Cl2 in the presence of AlCl3. Now, if you had the preparation of haloarene in your notebook, then I will tell you, go to the electrophilic substitution method for the formation of haloarenes. And you will be getting here chlorine. Once you have got the haloarene, then what you can do? Then you can convert this to biphenyl using your favorite reagent that we have till now, sodium in the presence of dry ether. Now, I hope you understand what is the importance of this reagent sodium in dry ether with respect to conversions. Right? So see, benzene and biphenyl. Okay, this is one of the repeated questions. This is repeated. So they have asked once benzene to biphenyl, and in one of the questions they have asked to diphenyl. Both biphenyl and diphenyl, they are the same thing. They are not different. Okay. Fine. So see, you can see 1, 2, 3, 4. So we have 4 questions that are from, there are 4 conversions which uses sodium in dry ether. So obviously sodium in dry ether is one of the important reactions here. Okay, now look at here, but1-ene to but2-ene. Okay, so now we will see very similar pattern here. 1-ene to 2-ene, 1 to 2. Then 1 bromopropane to 2 bromopropane, 2 bromopropane to 1 bromopropane. Okay, and in all of the cases that I have grouped here, you will be seeing that there is a change of functionality in adjacent carbon. Okay, so here the double bond was in the first carbon, now it is in the second carbon. What is but1-ene? But1-ene looks something like this, and but2-ene looks something like this. Fine. Now, whenever you have something like this, that is, here you can see that our alkene is what it is, less substituted. Can all of you see that? Yes or no? It has only one alkyl group. It has only one alkyl group. Can all of you see that? Yes or no? Please tell me.
Yes, sir.
And here it
Yes.
has how many alkyl groups? This product target material?
2.
2. So it is more substituted. Now, whenever you have something like this, whenever you are moving from less to more substituted or more to less substituted, then in both of the cases, you will be think of Markovnikov or anti-Markovnikov. Okay, so if I am moving from less to more, then I am going through the Markovnikov rule. If you are going more to less, then you are going anti-Markovnikov. Okay, so you have to think of Markovnikov or anti-Markovnikov. So first of all, you guys will tell me here. We are going from less to more, right? So Markovnikov addition will be happening, yes or no? Okay, what will be happening? Tell me. Oh, you guys remember Markovnikov, anti-Markovnikov, or you don't remember Markovnikov and anti-Markovnikov? Huh? You guys remember Markovnikov, anti-Markovnikov? Yes, Adriel, Fahad, Muhammad Umar.
The
Yes, yes, sir.
hydrogen gets added
Yes,
to
sir.
the
Right.
yeah.
Okay.
Yes.
So Markovnikov rule says that hydrogen will be added. So not hydrogen, rather I should say the negative part of the reagent will be added to that carbon atom which has less number of hydrogen. So in this we have 2 carbon atoms, and we are going to do Markovnikov addition. So we have this carbon atom that is yellow. This is the carbon atom containing less number of hydrogen. So if I am going to add HBr, okay, if I'm going to, now HBr is one of the very crucial reagent in the conversions. If I'm going to add HBr, I will be getting this product. Okay, now further I have to do what? I will convert this to alkene. Dehydrohalogenation. What is the reagent that we use? We used alcoholic AOH. And according to the Setzeff rule, what is going to happen? According to the Setzeff rule, we are going to get this more substituted alkene. We are going to get more substituted alkene. So you can see that I have used here the Markovnikov rules. Markovnikov. We have to make this product, na? Fahad, can you please turn the mic on? Please, na, those who ask question in chat, I really discourage asking questions on chat. Rather, please speak whatever you have doubt. Fahad, tell me.
Yes, sir.
This is my target material, right?
Yeah.
Okay, so we have to go. Now we have made haloalkane and we have to make alkene, right? So from haloalkane to alkene, what is the reagent? You don't remember. That is why you are asking, right? If you had that, see you.
Dehydrohalogenation.
Dehydrohalogenation, correct. So and we use alcoholic AOH for that. We are removing the halogen and we are removing the hydrogen from here, which is present, and we not show it in the bond line structure. All of you got this? Yes or no? Please tell me.
Yes.
Yes, sir.
Yes. Yes. Okay, fine. Now moving on. See, 2-methyl propene to 2-chloro 2-methyl. Now there will be a dash here. 2-methyl propane. Okay. So there is propene here and there is propane here. That is also you have to take care. 2-methyl propene. It is an easy question, by the way. 2-methyl propene. So we have propene, double bond, and there is a CH3 group here. And I have to make propane, and I have CH3 that was present here, and chlorine. So what is happening here? Tell me. We are moving from alkene to haloalkane. Now I would have asked you to look at the preparation of haloalkane using alkene. What is the reagent that we use here? Please tell me. And we are getting more substituted product. You can see that in the double bond, the chlorine atom is getting added on that carbon atom, which has least number of hydrogen. We are getting more substituted product. So if it is more, then what do we use? Markovnikov. Correct. So the reagent will be HBr. And sometimes you will see in some books, they write dark here. That means we are not doing in the presence of light. If light will be present, it will be forming some kinds of radicals, and then it will be doing anti-Markovnikov addition. That is why we usually write dark sometimes here. Okay. All of you got this? Yes or no? Please tell me.
Excuse me, sir.
Tell me, Sahil.
So how do we identify more substituted and less substituted in this one?
See, there can be two products. This is the pi bond. The addition will take place here. So what we can have? We can either have CH3 and the chlorine is getting added in this carbon atom. Okay. Or what can happen? You will have CH3 as it is, and the chlorine is getting added in the second carbon atom. Yes or no? There are only two cases.
Yes,
you can
sir.
either add the chlorine in the first carbon or in the second carbon. Now you tell me which is more substituted. The first carbon is more substituted or the second carbon is more substituted?
The first one.
First one. And what we are doing? We are doing the first one. And if we have more substituted product, that means we are using Markovnikov addition. Got it?
Right. Got it.
Okay. So if we had, let us say the product was this. We had this as the product. Then we would
It
have
will be-
used HBr peroxide.
Okay. It will be like less to more than.
No, it is neutral now. Alkene is neutral.
No.
We don't have any.
Okay.
Hello?
Got it. Got it. Yeah.
Okay. What will happen if I have to form this product from here to here? Then first I will be using alcoholic KOH. Okay, I will be using alcoholic KOH. It will give me what? It will give me an alkene. After the alkene, I will again use what? I will again use, okay, I cannot make, wait a second. This will be Br here. No, I cannot, we have here HBr. This will be HCl, by the way, not HBr here. Chlorine is there, my bad. Now alcoholic KOH, and we want to make this bromine in the more substitute. So in the second case, I will be adding here HBr in the presence of peroxide.
Peroxide. Right.
Okay.
Then we get
If I want to go
RBr.
from here.
Right.
Okay.
Got it. Sir.
Let's move on to but1ene. But1ene is this one, to N-butyl iodide. N-butyl iodide. That means you have N-butyl like this, 4 carbons, and then you have iodine here. Now again, you can see that we have to use anti-Markovnikov addition, but HI does not react in anti-Markovnikov. We can use only HBr. So first of all, I will make HBr like this. HBr in the presence of peroxide. It will give me Br like this. Then I will use the halogen exchange method using sodium iodide in acetone. Again, you can see now, whenever you will see this sodium, they will be specifying what is the solvent, but you don't have to go into the solvent chemistry. Why is acetone used? Acetone is again not water, and that is why sodium will not react violently with acetone. Acetone here is not a reagent. Please remember, it is neither a catalyst. It is just a solvent. Using halogen exchange method, I will get butyl iodide. Got it? Yes or no? I hope all of these reactions are very familiar. You have seen this reaction all in your copy. Yes or no, guys? Please tell me that. Yes, Adriel, Fahad, Kinza. Yes or no?
Yes, sir.
So this is halogen exchange, right?
Halogen exchange. Yeah.
Okay.
Okay. Now let's move to the next one. 1 bromopropane to 2 bromopropane. Now in this case, you tell me what we are doing. One bromopropane. So propane is like this. We have Br here, and I have to move to 2 bromopropane. Br here. So this is less to more. Correct? Yes or no? Yes or no?
Yes, sir.
है ना? So
Yes,
less
sir.
to more, that means we have to use Markovnikov somewhere. Now, in order to make Markovnikov, I need an alkene, right? Because Markovnikov addition, it happens only in alkene. So first of all, we'll make an alkene like this using alcoholic KOH. I will get an alkene like this, right? This Br will be removed, dehydrohalogenation. And then further what I will be using, I will be using HBr in dark. And that will give me the Markovnikov addition. See? Please think of it like this, okay? You identify less to more, and that is why, see, you identified what? You are going from less to more. This gave you information about Markovnikov. Okay, then in your head, you should be asking in Markovnikov addition, what is the starting material? So in once you got the Markovnikov, you will say we need alkene. Why? Because Markovnikov addition can only happen in alkene. If you need alkene, then you have to react with alcoholic KOH. Now, once you react with alcoholic KOH, you will get alkene. And when you get alkene, you will do Markovnikov addition, and then you will be moving less to more. See, so if you are going from top to bottom and then bottom to up again, can you see that, all of you? Please tell me.
Yes,
Can you
sir.
make out something from this chain? Okay, so
Yes, sir.
please keep reminding yourself of these things. These are the things that is going to help you in conversions. These reactions are not very helpful. You may know all the reactions, but still you may not know how to approach for the conversion. So this is the thought process that you should keep in mind. There are some little cues, I would say, cues, है ना? There are इशारे करता है, सवाल जो है ना आपको इशारे करता है, उन इशारों को आपको समझना है. You have to look at those signs, I would say, है ना? Cues or signs. Okay. Now let us move to the next one. That is very interesting. 1 bromopropane to 2 bromopropane. Now we are going to reverse. 2 bromopropane to 1 bromopropane. Right. So we have here Br, and I am moving to 1 bromopropane. Now see, again, what we are doing, we are going less. We are going from more to less. Right. If you are going from more to less, then we have to do anti-Markovnikov addition. So again, for anti-Markovnikov, what do I need? I need alkene. If I need alkene, then I will react with alcoholic KOH. So I will react this with alcoholic KOH first. I got alcoholic KOH. And then what I will do? Anti-Markovnikov addition. That means HBr in the presence of peroxide. So see how many reactions we have done with HBr. So now again, you know what is the importance of HBr. What is the importance of HBr? Okay. I hope you have grasped this, at least in your head. Now, see, this question here, it is playing with the naming. Okay, it is playing with the naming. Third butyl bromide. So we have a butyl group, which is tertiary in nature. So you have 4 carbons, and we have to make a tertiary carbon. So first of all, I will make a tertiary carbon like this. Carbon, 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 carbon. So CH3, CH3, CH3. So it is tertiary. There's 1 carbon tertiary, and there are 4 carbons that is making this particular tertiary butyl. And we have tertiary butyl bromide. So we have a PR here, tertiary butyl bromide, and we have to make isobutyl bromide. So iso, the concept of iso says that you should have this fragment. Okay, something like this should be present. That means if you break the carbon atoms from middle, you should get 1 CH3 here, 1 CH3 here. And we have to make this kind of group using again 4 carbon atoms. So I will make something like this. So we have made 3 carbons. This is my 4th carbon, and this is having Br group. This is having Br group. Now you may see that we are going from this carbon atom is more substituted, right? Now this carbon is only attached to 1 carbon atom. So we are going from more to less. If you are going from more to less, then we need anti-Markovnikov addition. For anti-Markovnikov addition, we need alcoholic KOH. And here I will get this carbon will be gone. This bromine will be gone, and you will be getting here CH3 carbon. There will be one double bond with CH2, and here you will be having CH3. Now I can easily react this with HBr in the presence of peroxide, right? And I will get what? The addition will take place on that carbon atom which is having more number of hydrogens. That means this carbon will get the bromine group. Okay, so this is only just a play with the name. There is no particular complexity in the reactions. Again, alcoholic QH, HBr peroxide, alcoholic QH, HBr peroxide. So this is one of the sequence which is very important. Can you write it, please? No, you may not. Force your brain to remember this. Force your brain to remember this. You have enough time nowadays for holidays, है ना? आप लोग लिख लीजिएगा, ये हमको पता है. But force yourself to remember all of these things. Pattern याद कीजिए ना, alcoholic KOH HBr, है ना? कुछ नहीं होता, ये use करके देख लीजिए, है ना? Draw the products. After that, see here now. Chloropropane to propane 1-all. Chloropropane to propane 1-all. What is chloropropane? 2-chloropropane also. This is my 2-chloropropane to propane 1-all. Now again you can see, first thing is that there is a difference in the function. There is the difference in the group that has been attached. We have chlorine here and we have OH here. But one thing is also sure, that we are going from more to less substituted. Whenever we go from more to less substituted, we'll be using anti-Markovnikov rule. Now when we use anti-Markovnikov rule, I need the alkene. I need the alkene. For alkene, we will use alcoholic KOH, and I will get propene. Now once I get propene, what I will make? I will make HBr. Okay, HBr in the presence of peroxide. Now, once I make HBr in the presence of peroxide, I will be getting Br like this. And once I get Br, I can simply use aqueous KOH. Okay, I can use simply aqueous KOH. Now, one way to do this problem will be, please see here. One way to do this problem would be, you have this chloropropane. Okay, and then you move to propane 1-all OH. Now you will ask, can I make alcohol from haloalkane? है ना? तो आपके दिमाग से या फिर आपके नोट से आंसर आएगा, yes you can, है ना? You can make alcohol from haloalkane. So if I have this alcohol, that means if I have propane 1-all, what should be my haloalkane? So my haloalkane should be something like this. Some X group here, है ना? Some X group here. Now you will see that, okay, fine, this is 2, that means this is more, and I have to go from more substituted haloalkane to less substituted haloalkane. That means I have to do anti-Markovnikov. Once you remember anti-Markovnikov, you will change this X to what? Br, because only HBr can do anti-Markovnikov addition. So this is the thought, this is the dialogue that should be going on in your head. And you should be talking with yourself when you are doing conversion. Now what I will do, now it is very easy. I remember the pattern here, alcoholic KOH. This will give me an alkene, and after that I will react this with HBr, the presence of peroxide, right? And I hope you know that this is aqueous KOH. So I have gone both ways. I started with the starting material, and I can also start from the target material. But you have to talk with yourself. You have to talk with yourself. You should have all the reactions at hand. Reaction at hand ka matlab, it should be present in your hands reach. Sare reactions, okay? All the chemical properties, all the preparation methods, and all the chemical properties and preparation. Those type of reactions hote hain. Those should be present in your notebook. Okay, 2-chloropropane to propane 1-all. Next one, see. Yeah, someone trying to say something? किसी को कुछ बोलना है? No. Okay. See.
No, we are just proving that ki how we get that.
नहीं, you have prove नहीं कर रहे हैं हम कि बना सकते हैं या नहीं. They will be these reagents are important, na? You have to write these reagents like this. This is how you are going to convert chloropropane to propane 1-all. Are you getting my point?
Yes, yes.
Yes. So they are basically asking, आप check कर रहे हैं कि do you know these reagents or not? How to do the conversions? Okay. Now conversion is a very good way to remember the reactions, by the way. Okay, to remember the reactions. Now look at the next one. Ethanol to ethyl fluoride. OH to ethyl fluoride. Now, if you look at the preparation of haloalkanes, and there is one section from alcohols, but from alcohols you cannot prepare fluorides. You cannot prepare alkyl fluorides. So first of all, we will convert this to any. We will convert this to, let us say, bromo or chloro. So SOCl2, and I will be getting here chlorine. Now, after that, I will be using what? Any metal fluoride, AgF, let us say. And this is halogen exchange method, right? This is what Schwarz reaction, right? This is the Schwarz reaction. So this is how you have to do the conversions. Everything is like, these things are very simple. There are a few reactions which are complicated that I will explain, and they're only complicated because they use first of all too many steps. That is one of the reasons. But the next reason is more important, that they use reactions from class 11th, and you don't even remember the reactions of haloalkane, haloarene. How will you remember the reaction from class 11th, right? That is why it gets tough. Let's move to the next one. Propene to propine. Now here you will write this complete thing, okay? But let me first explain what is propene. Which is propene, or rather I will make the open structure like this: CH3, CH double bond, CH2. I have to convert this to CH3, C triple bond, CH. So we are going to more unsaturated. We are going to more unsaturated. This is more unsaturated. Now, if you get more unsaturated, that means you have to use what? Elimination reaction. And the type of elimination reaction that we know from this chapter is only dehydrohalogenation. Dehydrohalogenation. So first of all, we will add the halogen, then only we can eliminate, right? So we'll add halogen, and as you can see here, we have two pi bonds, right? In order to get 2 pi bonds, I will add 2 Br. That means I will add here Br2. So what will happen? One Br will attach to this carbon atom, and the other Br will attach to this carbon atom. And this reaction is also there in your notebook in the topic bromination of alkene, and we get vicinal dihalides. We get what? Vicinal dihalides. This will be CH3, CH. We will get a Br here, and there will be a single bond now, and we will get CH2 and a Br here and a Br here. Now the next thing that we are going to do is we are going to use alcoholic KOH. What we are going to use? We are going to use alcoholic KOH. Now what can happen? One of the bromines and one of the hydrogen from other carbon. So if bromine is going from, let us say, this carbon atom, this hydrogen will be gone. And once that hydrogen is gone, you will get CH3 carbon. There will be a Br, double bond, CH. There will be double bond, okay, CH2 here. Now what we have to do? We will remove this bromine and one of the hydrogens from this carbon atom. Now, once alcoholic KOH is used and there is a pi bond here, we can't use alcoholic KOH once again, because OH negative is not such a good base that it will attack on the pi bond containing carbon atom. So we use more reactive base, that is NaNH2. So we do this reaction with NaNH2 and NaNH2, and you know that this reagent is also written in your notebook. You do NaNH2, and what you are going to get? You are going to get propine. Now, in order to do this reaction, you can also write like this. Instead of using alcoholic KOH here, you can also use NaNH2. So that will be a more simpler case. You can write here the first reaction that we are going to do is with Br2. The second reaction we are going to do is with 2 moles of, or 2 times, I would say, 2 moles of NaNH2. And we are going to get this propine. So please write this one. Please write this one here. And so the first thing, you can use both NaNH2 or alcoholic KOH. Okay, you can use here both or alcoholic KOH. But in the next step, you have to use NaNH2. There will be some books that will be writing here alcoholic KOH, but please remember, practically it is not possible to react any alkene with alcoholic KOH. Any alkene with alcoholic KOH, it will not give you dehydrohalogenation. Actually, write this one. This is important. So we have seen a new reagent now, NaNH2. Okay, a new reagent now, NaNH2 in conversions. NaNH2 is already there in your notebook, but this is a new reagent in the conversion. Write this down. Let me know when you are done. Done, everyone? Yes or no? Please tell me.
Sir, in the first part of the conversion, it is 2 NaNH2, right?
No, not the first part. Second part, no. Second step will be using NaNH2, ना 2 moles.
Yes.
ये देखिए, ये पूरा ऐसे करके एक cycle है, and whatever reagents we have used in this cycle here, from here to here, we have written this here and here. Okay. Are you getting my point, Fahad?
So in exam, exactly like this we have to do.
हाँ, exactly like this. Okay. You may ignore this one here. ऐसे आप इसको ignore कर दीजिएगा, but please make sure that you draw all the intermediate products that you are going to get. You may also not even circle like this things, but you get my point. Done, guys? Yes or no? Please tell me.
Just a minute, sir.
Okay. Now, so here we understand one more point. Whenever you are going from less unsaturated to more unsaturated, think of elimination reaction. Think of elimination reactions. That means if you have to go from single bond to double bond, or you have to go from double bond to triple bond, in both the cases, what you'll be thinking of? You'll be thinking of elimination reactions. Done, guys? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Yes.
Okay. Now we have to go from propene to propane. Okay, and there is one nitro group. So first of all, you tell me, can I make nitro from haloalkane? Yes or no? Tell me, can I make RNO2 from RX? Yes or no? ये रहता आपके पास नोट्स, तो आप क्या करते हैं? Chemical properties of haloalkane. You will go to that page and you will see that reaction है या नहीं, NO2 दिख रहा है या नहीं दिख रहा है. Yes or no? जल्दी बताइए. Can I move? Can I go from? Can I make RNO2 from RX? Yes or no? Can I make a nitro group from haloalkane? Can I make nitroalkane from haloalkane? Okay. What is the reagent, Fahad? What should we use? Which reagent should we use? Yes बोलने से काम नहीं चलेगा. Reagent बताइए. What reagent? अरे बहुत बड़ा बड़ा लिखाया हुआ है इसके बारे में. तो there is at least one page regarding this. Look in your notebook, guys. Look in your notebook. What is the reagent that we are going to use? Yes, Abdur Rahman. No, not KNO2, AgNO2. There is a question also we have written. Why the reaction with KNO2, it gives ONO, or ONO is given by KNO2. But if I react with AgNO2, I get RNO2. We have written this question also, but still, ये revise करने से ही आता है, ऐसे तो कुछ नहीं आएगा. Okay, and here the haloalkene will look something like this. Everything as it is, and here we have, let us say, Br. Okay, and you can see already we have to go from propene to, what will be the reagent here? Tell me.
HBr.
HBr.
In dark.
Dark या dark? अरे dark में more substituted होता है भाई. Peroxide. Anti Markovnikov है ना? Not dark. Peroxide. रिवाइज कीजिए भाई, आप लोग रिवीजन चालू कीजिए, ऐसे काम नहीं चलेगा. प्रोपेन टू प्रोपेन 1 और have we done this reaction? No. We can make. Can we make alcohol using haloalkane? Yes. What will be the reagent now? Tell me. What will be the reagent here?
Same
HBr.
HBr in presence of peroxide.
Peroxide is a reagent here. Okay, please remember that. HBr is also a reagent. Peroxide is also a reagent. Okay. Ethane to bromoethane. This is very easy. CH3 to CH3 CH2 Br. So we have to make haloalkane from alkene. There is only one method that you should remember is halogenation in the presence of helper, heat, electricity, light, or peroxide. So Br2 in the presence of what? HNu. Br2 in the presence of HNu will give you CH3 CH2 Br as one of the project. Okay, so this is a simple reaction. Let's move to this one. Toluene to benzyl alcohol. This is important. Please remember this. What is toluene? Benzene ring here with a CH3. Okay, this is toluene. I have to make what? Benzyl alcohol. Now, if you don't know what is toluene, then you will make a mistake. Now, benzyl alcohol is not this one. Okay, this is phenol. This is not benzyl alcohol. Please remember this. What is benzyl alcohol? If you remember benzyl halide, you should remember benzyl alcohol also. So what is benzyl halide? You have a CH2 that is attached to benzene ring, which is further attached to what? Halogen atom, but here we have alcohol, so it will be OH. Important thing to note down here is whatever reagent we are going to use, it is not disturbing my benzene ring. The benzene ring is as it is. The reaction is happening on the sp3 carbon. See, these are the things that you have to remember. If this carbon is sp3, that means what is this? This is a alkane. This portion, whatever the reaction is happening, it is happening in the alkane side. It is not including anything regarding the aryl group or the benzene group. Okay, so we have here CH3 and here we have OH. So first of all, you will ask yourself, we have alcohol. Can I make alcohol using haloalkane? The answer should come yes. I will use this benzene ring, and what I will be using CH2, let us say Cl. And can I make haloalkane using alkenes? So the answer will be yes, we can. And the reagent that we'll be using will be Cl2 in the presence of H nu. So I hope you understand that the reaction is happening in the alkane part of the alkane fragment of molecule. I hope all of you can see this. So first of all, see, we have gone in a reversed way. So this is also one of the way that you will go. If you see anything other than, if you see anything which is what, which is not haloalkane, then you'll ask that, can I make this from haloalkane? If the answer will be yes, then you'll form the haloalkane that is going to make this one. And we'll be using the reagent alcoholic KOH, sorry, aqueous KOH, my bad, to convert this chlorine to OH group. Okay, to convert this chlorine to OH group. Now, again, this reaction is also what? Very common reaction. Okay, there's nothing special about here. Next one, right? Ethanol to propane nitrile. Now, here you can see that we have 2 carbons here, and here we have 3 carbon. Whenever you are increasing 1 carbon, okay, so whenever there is increase of 1 carbon, think of KCN. Okay, so ethanol, we have OH. You have to convert this to propane nitrile. So propane nitrile is CH3, CH2, and there will be CN here. So I should write it like this. CN. We will be directly using KCN. Okay, we'll use KCN here, and I will be getting propane nitrile. KCN and then propane nitrile. Okay, write these 3 reactions.
So can you show the last slide?
Last slide, yeah. Oh, sorry. My mistake here. OH group will not attach, react with KCN. First, I will convert this to haloalkane. I will have Cl here using SOCl2, and then this will react with KCN. Okay, my bad.
So we should write this one or the next slide?
No, you don't have to write this one. You have to write this one.
Okay.
Did all of you write this? Yes or no? Please tell me. Write this down. I will explain these three reactions. Now, NCERT should have put some of the conversion in the chapter nitride or the chapter dealing with amines, not nitriles, but they have given you here. So you have to know these three reactions at least. Okay, that will be helpful. Done, guys? Yes or no? Please tell me.
Yes,
Done,
done.
sir. Done.
Done. Okay. So see, the first reaction, please understand, we have RCN. So what happens? There will be water molecule. And what is water molecule? Water molecule is HOH. It is HOH. So one water molecule attaches like this. One hydrogen here, and one more water molecule, it attaches like this. Okay, so you can see that there will be double bond forming between carbon and oxygen, and there will be OH bond forming between carbon and oxygen here. And this NH3 will go as it is. Okay, can you see NH3? So that is why you get what? Carboxylic acid, and there will be NH3 formed. Ammonia. If you react this with water, So pani daliye on nitrile. If you add water, you will be getting what? You will be getting carboxylic acid. Now let's look at the third one. Let us look at. So we have LiAlH4. It is what? It is reducing agent. It has many H ions. Okay. You have hydrogens, many hydride ions you will be there. So what happens? H2 is added on carbon here, and NH2 is added on this nitrogen here. So simply you get amine. Simply what do you get? Amine here. Now this reaction with Grignard reagent is very important. So let us look at this reaction first. We have RCN, and I am taking a case of CS3MgBr. CS3MgBr. So first reaction, what happened? We have here delta negative because magnesium is what? Electro positive element. It is metal. It has a tendency to lose electron. It gets delta positive and it gives electron to CS3. This CS3 attacks on this carbon atom because carbon is attached to nitrogen, and hence carbon will get a delta negative charge, and you will be forming here R. Now, as soon as there will be a bond formation between CS3 and carbon, one of the pi bond between nitrogen will break, and you will be getting RC double bond nitrogen, and this carbon will get the CS3 group. Please remember that this CS3 group is coming from, let me write this in some different color. This CS3 it is coming from the Grignard reagent. This CS3 is coming from Grignard reagent. Okay, the CS3 is coming from Grignard reagent. And we have the other thing as it is. We have here nitrogen and attached with MgBr. Now, after that, we add water. This is my first step in which we add RMgBr, and then we add water here. Now, when we add water here, what is going to happen? Water will add like this. You have O, and there will be hydrogen and hydrogen here, hydrogen and hydrogen here. So this carbon will form a double bond with oxygen. Okay, and this will break off like this. So you are going to get what? R, C, double bond O, and this CS3. Please see the importance of Grignard reagent. This CS3 is coming from what? From the Grignard reagent. It is coming from the Grignard reagent. So here we have R plus 1 carbon atom. Here we have R plus 1 plus R dash carbon atom. So whatever is present in the Grignard reagent, it will be added on that carbon atom which has nitrogen. Okay, so this is very important. I have shown you this example. Let me explain it once more. We have nitrile group. In nitrile group, the carbon atom containing the nitrogen, it has delta positive charge due to the electronegative, high electronegativity of nitrogen. And this CS3 is attached to Mg, and this CS3 attacks on the carbon of nitrogen because of delta negative charge on CS3. And once it attaches, this pi bond breaks, and you get an addition product, which is R carbon, which is attached with the CS3 of Grignard reagent, further attached with nitrogen with a double bond and MgBr. After a reaction of water, this oxygen attaches with this carbon atom. The double bond between nitrogen breaks, double bond between the oxygen forms, and this H2 is left with the nitrogen atom here. And we get here a ketone. Okay, so I hope all of you got these three reactions. You add water, you will get carboxylic acid. you add Grignard reagent, there will be an addition of the R group of Grignard reagent. You add LiAlH4 and you will be forming amines. You will be forming amines. Okay. Now, based on this particular reactions, we have some reaction. For example, bromomethane to propanol. So we have starting with bromomethane. So we have here CS3 and Br, and we are going to propane. So propanol. That means it is CS3, carbon double bond O, and then CS3 again. So I hope you can see what we are forming. We are forming propanol. We have not looked at propanol anywhere except that nitrile reaction. So what we are going to do here, we are first of all going to form KCN, and with KCN I will be getting CS3 CN. After this I will react this with CS3 MgBr because I have a CS3 group extra. I have got these 2 carbon atoms, right? Now it is very important reaction. I will show you why. I will show you why. It is again. I will show you why it is very important. We have here, let us say, KCN. Now this CS3 is there, and you are getting CN from the Grignard reagent. Okay. No, sorry, we are getting the CN from KCN, and after that we have CS3 MgBr. Now this CS3 MgBr will attack on this carbon atom, and you will be forming what? We will be forming CS3. This is coming from bromomethane. Then you have the carbon atom that is coming from the KCN. This carbon is coming from your KCN, which has a double bond with nitrogen now. And what is attaching on this carbon atom now? We have a CS3 group which is attaching here. We have a CS3 group that is coming from the Grignard reagent. Okay. And we have MgBr here. See how beautiful this reaction is. After that, we are adding, let us say we add here now water, right? In order to get a ketone. When we are adding water here, H2O, this oxygen atom is getting attached here on the carbon. So this product that you are seeing here, we have made this product using 1 atom from each of these things. So here, which color is this? We are green. So oxygen is coming from water. This carbon which is in the middle, it is coming from the KCN. Then we have this CS3. This CS3 is coming from the Grignard reagent. One of the CS3 is coming from Grignard reagent. And this CS3 is coming from bromomethane. So please write this reaction. It is very important. Very beautiful reaction also. So in the product, we have 4 main atoms. All of these 4 main atoms are coming from 4 different reagents. They are coming from 4 different reagents. I hope now you understand this reaction. Yes or no? Please tell me. Not much difficult, right? This whole conversions, all these steps. Yes. Okay. Fine. What about others? I'm not getting any answers from others, huh? Abdurrahman, Adriel. Yes. Okay. Fine. Okay. So there are reactions which are left. So I think we will be doing this on. We'll be doing this on the next class, that is on Monday, and then we'll start alcohols on the same day. Okay. Now, since you have test, I will give you 5 minutes so that you can revise a bit. Okay. And then the test will start. I will not be conducting the test. There will be someone who will be conducting the test. If you have any doubts, then you can. Yeah, it is compulsory to give the test. Test. Okay, Fahad, it's compulsory to give the test.
Sir.
Yes, tell me.
Sir, I actually completed the nomenclature, and that one question I have a doubt. So shall I send you the photo in WhatsApp?
Sure. Also, one more thing. You don't have to wait for the classes to ask doubt, okay? Now, what I personally encourage is that as soon as you get doubt,
I'm hearing
message.
Sir.
Okay, message me immediately.
Oh, okay, fine.
Okay, message me immediately.
I had this out yesterday itself, but I waited for the class. So
I am saying, I am not saying that I will answer immediately. I'm not saying that. Okay, please remember. As an I just keep on waiting for a doubt to come from any student, and I'm there always on WhatsApp. I'm not there always on WhatsApp, but I will reply somewhere between. I may reply immediately also. That I try to do. If that can be answered in less than 2 minutes. Not only doubts. If there is anything which can be done in less than 2 minutes, I do that thing immediately. Okay. So if my notifications are on, if I see those questions, then I will answer it immediately. Don't worry about that. But
Yes, sir,
again, I check my phone approximately in every, let us say 1 hour. Okay. I get my phone in my hand. So I will answer you within 1 hour. I'm
Sure, sir.
asking you guys to send the doubt immediately because Mithun, आप भूल भी सकते थे, right? You would have forgotten this doubt, right?
Yeah, yes, sure.
That is why I'm asking that you have to send it immediately.
And if I just keep it, the result means maybe after 1 month question comes, means same issue.
Oh, yes, immediately भेज दिया कीजिए, okay, immediately. Okay, अब फहद आप दीजिए ना टेस्ट, क्या हो जाएगा? बोर्ड्स पे हम सीबीएसई को मार्क्स नहीं भेज रहे हैं ये, okay, फहद. Are you listening, Fahad?
Yes, sir.
ठीक है, कीजिए, ठीक है ना?
Okay.
आप टेस्ट दीजिए, जब आप टेस्ट और all of the questions that is present in the question paper, they are from the CBSE papers only, the past previous year questions of CBSE. Okay, so you may also get a hang that how the question comes. फिर जब आप सवाल लगा के पढ़ते हैं ना, जब then you know what is important and what is not important. So like how I teach is that, like whenever I have to teach something, I will start with, if there is something new, then I will start with the questions only, the in text question, then the end text question, है ना? So once I get an idea that how the questions are being framed, then I know which are the portions which are important, which are the portions which are not important, and they don't ask directly questions from there. Okay, so I look at the NCERT questions, then I look at the previous year questions, then only I take the class. Okay, so whenever you are studying, आप ये चीज follow कर सकते हैं आप भी, that what you do, you start and look at the questions that you have in the exercises and then start. Okay, chalo, I think I should leave and I should ask someone to show the question paper. Wait a second. Let me call them. Acha, one more thing, you will send all the answers to me. Okay, there are instructions in the paper, by the way. Don't have to worry much. There are instructions. Okay, guys, I will leave now. Okay, if you have any doubts, you can message me on WhatsApp, okay, regarding the paper. Acha, for the fifth question, I may just tell you now. You have to tell me whether the state of solute in the solution it is associated or dissociated. You may think कि आपको क्या बताना है? So you just have to tell me whether it is associated or dissociated form. Okay, for the fifth one. Chalo. Thank you guys. Thank you very much. We'll meet on Monday now. Bye bye. Take care. All the best also.